everyone. So today we are solving this problem, find minimum time to reach last room 1. So there is a dungeon with n cross m rooms arranged as a grid. So dungeon is nothing but a kind of a prison inside some cave kind of thing. Okay, so you can consider just a 2D array of the rooms, and you are given a 2D array name is move time of size n cross m, and move time ij represents the minimum time in seconds when you can start moving to that room. So we are starting from 0 0 coordinate at time t0 and can move to adjacent, means left, right, up and down. We cannot move to diagonally. So moving between adjacent rooms takes exactly 1 second. So we have to return the minimum time to reach uh, the last the bottom rightmost element. So we can take an example here. For example, in the question itself, we have given this one 0444. So we will take this example. So we can put it here 0 and 4, and this is 4 and this is 4. Okay. Now we have to start from this cell. Every time we have to start from very first cell, and we have to reach this rightmost bottom cell. So what does it mean here? 4. 4 means at the time 4 only you can read. Just like we go to a movie hall, right? If we go to a cinema hall to watch a movie, if it is starting at 10 a.m., right? If it is starting at 10 a.m., then before 10 a.m. we cannot enter into the cinema hall, right? Same way, this is the time. So to reach this room, for example, we have to come either at time equal to 4 or greater value. Similarly, if you want to visit the cinema hall of so 10 a.m., you have to either come at 10 a.m. or maybe later part as well. 10:30 also you can enter, but you cannot enter before 10 a.m. Similarly, before this time you cannot enter to this room. This is what it means. So as per it is given in the question, this cell value is basically the time at which if you want to come to this cell, let's say the value is 4, so you should move from this cell at 4 only. Similarly, for wherever you want to move, you have to start at the time of the target cell. Okay, so for example, if we want to solve this problem for this grid, we will start from this, right? So if we, let's say we are starting from here, so we can start here. If we want to visit this cell first, we have to start from at 4, right? So at t equal to 4 we will start if we want to reach this cell. Okay, so at t equal to 4 we will start, and to reach this cell it will take 1 second, right? So we are adding 4 plus 1. So total here we have taken 5 seconds. Okay, to reach this cell we are taking 5 seconds to reach this cell. Now our target is to reach this rightmost bottom cell, right? This is our target cell. So if we move from here to here, you can see currently the time is already 5, which is greater than this time, right? It should be greater than or equal to. If we want to move from any cell, which is 5 is greater, so we can move, and it will take another 1 second. So what will be the total time? 5 plus 1. Okay, so 5 plus 1, it is taking 6 seconds, right? Similarly, we could have moved here also, right? Then again it would be, so there you can imagine, this is only one simplest example, but imagine there could be like a huge number of cells, and we have multiple routes, and we have to find the best way which will take the minimum time. So we have to solve for that. So what would be our approach is basically, you can observe here one thing, that whenever we are reaching to any cell, we have 4 possibilities, right? All the 4 directions we can move. So if we can move all the possible 4 directions, we have to basically take care of what all moves we can make. So if we know that if we are at any ij, right, at any ij we can move to 4 directions. That means up, down, left and right, right? So those moves we can easily get if we can have those coordinates, right? We can have 0 1 move. Okay, that would be the right move. We can have the uh, uh, 1 and 0 move, which would be to the which will be to the bottom side, right? We can also have the 0 and -1 move, means for the left side. and we can also have the -1 to 0 move. Basically all the 4 horizontal or vertical direction, what I mean to say. These are the possible 4 directions. We cannot go to the diagonally directions. Now, after reaching to all these 4 directions, we have to find the best path to reach this last cell. Okay, so at every time we could have multiple possibilities, and we cannot repeat the same cell again, because it is possibility that if we are moving horizontal or vertical, we might come to again for the same cell. So we have to avoid those kind of situations as well. Okay, so here we will use the Dijkstra algorithm. Okay, if you don't know about the Dijkstra algorithm, I have put the link of the Dijkstra explanation. You can watch it. Okay, so we will solve it in that way. So how does Dijkstra algorithm works is basically it. So here is my code that how to solve this problem using Dijkstra algorithm. So see here. Uh, Initially, I'm taking the length of rows and columns. Okay, and these are the 4 directions possibilities, because we can move up, down, left, and right. So these are the coordinates to add for any coordinate to the next cell, which is vertical or horizontal in both direction. And then this is our answer array, which has like a similar kind of this is a 2D array I'm creating, and also we need a boolean visited array. Okay, because we need to keep track of what all sites has been visited or not. For example, let's say we are moving from this cell. Okay, we move for right, then we move one more right, then down, then up. In that case, what will happen? At this location, we are again coming to an already visited cell, right? So to avoid this, we need to keep track that what all things, what all cells are already visited. So for that reason, I am creating this boolean visited array of same length m and n. Now we are creating a priority queue, and in priority queue you can see the data type we are storing is cell. So what is cell is, the cell is basically the coordinate of any cell I and j, which is the xy coordinate of it, and the time given to that cell. So I am just I created one class to store that into the this priority queue, and this priority queue is the minimum min heap kind of thing based upon the time. So smallest time would be on the top of the priority queue. Okay, now here what I am doing is, for this dist array I'm initially putting all the values as max value, the distance max value, or you can say the time max value. And for very first cell, what we are doing, the very first cell, the time taken would be 0, right? So that is why I'm taking for this 0 0 equal to 0. And then we are creating a cell for very first cell, which is 0 0 0 0 coordinate I and j 0, and the time is also 0, and I'm adding that cell to the priority queue to get started. Now what we'll do is, while PQ is not it is not empty till the time we are running this while loop, and we are popping out the cells from this priority queue. Okay, now see here what I am doing is, first of all we have to check that the coordinates of this cell, if it is already visited, there is no point of processing it again. So that is why I am making it continue. Otherwise what we are doing, we have to proceed it, we are making it true first, and then we are looking for all the 4 possibilities. For example, just like let's say we are at this cell, then we have this possibility, we have right possibility, we could have it up possibility and left possibility. All possibilities could be there, right? So for that reason what we are doing, we are getting all the coordinates. So if we are at I and j, then we are getting all the possibility of x and y coordinates, as we have created already these 4 possibility coordinates. So what we are doing here is, we are taking all the values if they are going, so all the new xy values, if they are going beyond the boundaries, we are definitely continuing it. Otherwise, at line number 41, what we are doing here is, we are getting the maximum value of from which cell we are moving, whatever is the distance of that, and the maximum value of the cell for which we are moving. Now what does it mean is, we can take a simple example. For example, we are going to watch a movie at the 10 a.m. So, okay. So if we are at this time, if we are reaching at 8:30 a.m., then also we will be enter at 10 a.m. only. Or if we are using, if we are reaching there at 10:30, then also we can only enter at 10:30 because we cannot bring back the time. So all the possibility, every time we are taking the maximum value plus 1. This plus 1 is basically we take the 1 second to enter to the new cell, adjacent cell. Now what we are doing is we are taking this answer variable. We are checking for this xy coordinate. If distance is greater than the time value, the new value, then we are updating this dist xy equal to time value because we are finding the minimum value. And for this xy cell, we are creating a new cell and adding it to the priority queue. Okay. So when we will come out of this while loop, when every cell would be visited, everything would be true. Okay, all the values in visited boolean array would be true, and we will come out of this loop. And this distance would be having the answer for this last cell or for every cell. So m minus 1 and n minus 1 is the cell, and we are returning it. So let me try to run it. So yeah, it is working. Let me try to submit it. Yes. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.